This video will be about integration by parts. So integration by part is a technique that you can use when you're integrating functions that are products. I'm going to start by giving the formula, which might not make sense at first, but then I'll give some examples of how to work it, and then it should be clear. So if you're given an integral of u dv, where u and v are both functions, then you can rewrite the integral as uv minus the integral of v du. Now let me give an example of how it works. Let's say we have the integral of x times e to the x dx. Now, using the integration tools that we already know, we wouldn't be able to solve this. So what we can do is use integration by parts. Recall our formula is the integral of u dv equals uv minus integral of v du. Now, so what I'm going to do here is I'm going to set u equal to the function x, and I'm going to say dv is equal to the function e to the x dx. And so at this point, all I have to do is plug things into the formula. And in order to do that, I'm going to have to figure out what v is, and I'm also going to have to figure out what du is. So I'll go ahead and do that. Du is just equal to dx, and v is equal to e to the x, just by integrating normally. And so now I can say that our integral equals x times e to the x minus the integral of e to the x dx. And we already know how to integrate this, so we can just go ahead and write our final answer, which is x e to the x minus plus c. And now, just to prove to you that it does work, I'm going to take the derivative of this and make sure that it's what I started out with. So using the product rule for our first term, we have first times derivative of the second, which is just e to the x, plus the second part times the derivative of the first, which is 1, and then the derivative of minus e to the x is just minus e to the x. And so that simplifies to x e to the x, which is indeed what we started out with. So how do we know which part of the function is u and which part is v? There's a little acronym that can help us. It's called Blipit, and it stands for logarithms, inverse trig, polynomials, exponents, and trig. And this acronym is used to help us decide u. So in other words, when you're trying to choose which one is u, first you're going to look and see if there's a logarithmic function. If there is, then you'll set that to u. If there's not, then you'll look for inverse trig, and etc. You'll just go down the list until you find one that fits. Sometimes when you have a more complicated integral, you'll have to use integration by parts multiple times to get your answer. To simplify things, we can use something called the tabular method. So the way it works is you have the integral of u dv. We can create a little table of u's and v's. So we start out by just writing u and dv. And on the u side of the table, you're going to take the derivative at each step. And on the v side of the table, you're going to integrate on each step. Now let me give an example to show how this works. So let's say I want to integrate x cubed times sine x dx. Using my method Blipit, I'm going to assign u to be the polynomial. So u equals x cubed, and dv will be sine x dx. Now on both sides, I'm just going to continue down, taking the derivative or integrating as appropriate. So we'll have 3x squared, 6x, 6, and then 0. And on the v side, I'm going to have minus cosine x, minus sine x, cosine x, and sine x. Technically, I should have plus c's on all of these here, but we're just going to ignore that for now. Now, a really important step is we're going to alternate subtracting and adding. So we start out, first one is a plus, minus, plus, minus, plus, and you would keep going down if there were more. And then you're going to go diagonally, taking the products. So what this means is that you would have a plus x cubed times minus cosine x, and then minus 3x squared times the minus sine x, plus 6x times cosine x, minus 6 sine x. And from this point, you can just simplify all of your pluses and minuses to get your final answer for the integration.